So now that we've added basic collision to our player and to the test platform, let's look into how to actually make the player move left and right. We're going to go into our scripts folder and create a new C# script, and we're going to call this player. We'll open up the script in MonoDevelop, and we're going to need to add two new properties that are going to represent the speed and the maximum velocity at which our player can actually move. You'll see here that I'm creating the public float for speed and saving it as 10f. And we'll also need a variable, which will be a vector2 to represent our maximum velocity. For its x value, we'll set it to 3, and for its y value, we'll set it to 5. We're not going to need the start method, so we'll just delete this from the script for now. Inside of our update loop, however, we're going to want to make sure that whatever force that we apply to the player gets cleared after each new frame. In order to do this, we're going to have two variables that represent our force x and our force y. These are going to be floats, so we'll set them to 0f. Next, in order for us to calculate whether the player is moving faster than its maximum velocity x, which we have already set, we're going to want to get the absolute value of the rigid body's actual velocity x. Since the rigid body velocity x can actually be a positive number if the player is moving to the right or a negative number if the player is moving to the left, we're going to use the absolute value, which will just return the number itself. In order to do this, let's set up a new variable here called ABS velocity x. And we're going to use the mathf library with its ABS method to get the rigid body 2D's velocity x value. Now we're ready to start capturing the right and left key clicks. We can set up a new conditional using the input class to get the key, and here we're going to type in right for the right key. Also, let's set up another conditional in the else statement to test for the left key. Again, we'll use the input class, get key, left. You'll see that sometimes as you're typing, MonoDevelop will accidentally shift over the formatting. You can simply select each of these lines and by holding down Shift and Tab, move them back into place. Now, for the right key, let's test that the absolute value x is less than the maximum velocity x. So here we'll use absolute value x is less than maximum velocity dot x. And since this is a simple condition, I'm not going to use the open and close brackets. I'm just going to go to the next line. For this, we're going to set the force x to equal the speed. Now, we're going to do the same thing for the left key. So we can copy this block of code and paste it below. The only difference here is that we're going to set the speed to negative. This way, the player will actually move to the left. The final thing that we need to do to actually make the player move is apply a force to the player's rigid body 2D. So here you can see we're calling the rigid body 2D. We're adding a force. This is going to be a new vector2 since this is part of the 2D engine. And we're going to apply the x value to be force x and the y value to be force y. Once you save this, we'll go back into Unity and make sure that there aren't any errors. It recompiled and nothing showed up down here, so we're good to go. Now drag the player script onto the player into the scene. If you select the player itself and scroll down, you'll now see that we have the player script attached. We can also change the speed and the maximum velocity x and y value in the inspector itself. Let's run the game, and we'll move the player to the left and to the right and see that they correctly move. The one thing you may have noticed is that the player doesn't actually face the direction that he's moving in. We'll go back into our script, and we'll add a few lines of code to help make that happen. Inside of where we test for the right key, we're going to change the transform's local scale to allow us to flip the player from left to right. Here we'll start typing out transform, local scale, and we're going to create a new vector3, and in it we're going to set the values to 1, 1, 1. Let's copy this and paste this into where we test for the left key. Here we're going to change the x value of this vector 3 inside of the left condition to -1 so that the player's sprite turns to the left. We'll save this script, go back into Unity, make sure we don't have any errors, and rerun the game. Here you'll see if we move left and right, the player will now also look in the direction he's moving. If we click on the player, we can also see that here in the scale x value, and we click back in the scene to get focus, as we move back and forth, the scale x moves along with it. The last thing we want to do before moving on is click Apply so that all the changes that we made to our player game object are now applied back to its prefab, and we can save the scene.